Quantum Mechanics by Maple. Part 13. Mathematical Tools in Quantum Mechanics. Ordinary Differential Equations. Quantum Mechanics by Maple is a complete course, contains 38 videos for beginners. During this course, student will be able to use Maple step by step in quantum mechanics. The first 10 videos of Quantum Mechanics by Maple introduce and discuss computations and the types of computations, including symbolic and numeric computations. Moreover, they discuss how to reduce the errors and restricting the domain for performing computations in the real number system. From the 11th video of this series, we will introduce and discuss mathematical tools in quantum mechanics, with performing computations for them. The 11th video of Quantum Mechanics by Maple discusses equations in physics and solving equations. The 12th video of Quantum Mechanics by Maple discusses inequations in physics and solving inequations. This video is the 13th video of Quantum Mechanics by Maple and discusses ordinary differential equations in physics and solving this type of equations. As it expressed earlier, in 11th video of this series, about equations and solving equations, equations are one of the underlying tools in science and especially in physics, because 1. The laws of physics are usually expressed in terms of equations. 2. The equations relate physical quantities to each other and perform computations. The most important type of equations, in science and especially in physics, are differential equations, because the world is in permanent motion. In nature nothing remains constant. Everything is in a perpetual state of transformation, motion, and change. Motion is the mode of existence of matter. To be means to be in motion. The world is integrating and disintegrating. It never attains ultimate perfection. Heraclitus says, everything flows. So, the equations in physics must express the perpetual state of transformation, motion, and change. In order to express the perpetual state of transformation, motion, and change, science uses a special type of equation. This special type of equations in science and particularly in physics is called differential equations. As in philosophy, dialectics enables us to see things in perpetual state of transformation, motion, change and their connection. In science, differential equations enable us to see things in perpetual state of transformation, motion, change and their connection. That's why we use differential equations for expressing the laws of physics. Maple can solve ordinary differential equations, ODEs, and ordinary differential equation systems, ODE, systems including initial value and boundary value problems, symbolically and numerically. In order to perform computation and solve ordinary differential equations by Maple, we can use the following methods. 1. Using ODE analyzer. 2. Using dsolve commands. 3. Using context menus. In order to illustrate and discuss these methods, we are going to solve the following example by Maple. At first, let's explain how to type the example in Maple. To insert a symbol, we can use palettes or symbol names. In order to enter the derivative symbol in the calculus palette, click the differentiation item. Maple inserts the derivative. Replace the placeholder f with the function yx equals 2yx plus 1. Now, we are going to solve the example by Maple. 1. The first method, using ODE Analyzer. The ODE Analyzer Assistant is a point-and-click interface to the Maple ODE solving routines. To open ODE Analyzer, from the Tools menu, select Assistants, and then ODE Analyzer. The ODE Analyzer Assistant is displayed. In the main ODE Analyzer Assistant window, you can define ordinary differential equations, initial or boundary valued conditions, and parameters. After defining an ODE, you can solve it numerically or symbolically. The second method, using dsolve commands. For ordinary differential equations, or systems of ordinary differential equations, the dsolve command can find closed form solutions, numerical solutions, series solutions. In addition, the dsolve command can find formal power series solutions to linear ordinary differential equations with polynomial coefficients, formal solutions to linear ordinary differential equations with polynomial coefficients. To access all available functionality, use the dsolve command directly. The third method, using context menus. To using context menus, we will follow the following steps. 1. Right-click the equations. 2. From the context menu, select Solve DE or Solve DE interactively. 3. If you select Solve DE, then Maple computes exact solutions. 4. If you select Solve DE interactively, then ODE Analyzer Assistant is displayed. After defining an ODE, you can solve it numerically or symbolically. In the next video, we will discuss more about ordinary differential equations.